contributions to space exploration, front and center. The planet in question is remarkable not only for its size and peculiar location in the universe, but also for exhibiting a phenomenon that has experts in awe: light that appears to be artificial emanating from the planet. This disclosure brings up significant issues. Would we say we are on the cusp of revealing mysteries that could change how we might interpret the universe? Could this enigmatic light serve as a warning or beacon that other planets may have intelligent life? The repercussions are staggering, and as we investigate NASA's amazing findings, we may soon come face to face with facts that have the potential to alter our perception of reality itself. In 2007, NASA set out on a mission that would additionally solidify its heritage as a trailblazer in space investigation. The Daybreak space apparatus, a designing wonder furnished with 3 cutting-edge particle motors, was sent off with a solitary objective: to investigate probably the most baffling items in our planetary group. The first step on Dawn's journey was a 14-month investigation of Vesta, the second-largest asteroid in the asteroid belt. The information and images that Dawn sent back to Earth shed new light on this enormous space rock, which had previously been shrouded in mystery. The findings of the spacecraft revealed a world of astonishing complexity, with a geologically rich surface that spoke of ancient collisions and cosmic forces that gave it its current shape. However, Vesta was only the start. Dawn's mission was by no means finished. The spacecraft was given the even more ambitious task of taking a close look at Ceres, a dwarf planet, after it had completed its in-depth investigation of Vesta. This progress denoted a critical achievement in space investigation. Dawn was able to escape Vesta's gravitational pull and set course for Ceres thanks to the ion engine's gentle but constant thrust, a feat that conventional chemical propulsion systems would have found impossible. Dawn was able to travel a great distance thanks to its slow and steady travel, which eventually placed it in a stable orbit around Ceres, where it would begin the next phase of its mission. As the largest object in the asteroid belt, Ceres, which was discovered in 1801 by the Italian astronomer Giuseppe Piazzi, holds a special place in astronomy history. At first celebrated as the littlest known Bantam planet, Ceres was renamed in 2006, further fascinating researchers and space experts the same. Ceres is not only the largest but also the most massive object in the asteroid belt. It has a diameter of about 950 kilometers. Researchers have long been intrigued by its distinctive features, which set it apart from other celestial bodies in the area. The scientific community eagerly anticipated the first detailed images of Ceres' surface as Dawn approached this mysterious world. Every expectation was surpassed by what they discovered. Particularly within a vast crater known as a crater, the images revealed a surface dotted with bright spots. Scientists were immediately captivated by these bright spots that were dispersed like beacons across the dark, rocky terrain. The disclosure ignited a flood of hypotheses. What might these brilliant spots at any point be? Prior to Dawn's mission, the Hubble Space Telescope's best images of Ceres were blurry and low resolution. These brand-new high-resolution images promised to reveal secrets that humanity had been unable to discover for centuries. One of the critical targets of the Sunrise mission was to improve how we might interpret the planetary group's arrangement, especially the job water played in the advancement of planetary bodies. Other celestial objects' bright spots on Ceres appear to be made of highly reflective materials, possibly salts formed when water was sublimated. A groundbreaking theory emerged as a result of this revelation. Ceres might be experiencing cryovolcanism, a process in which volcanoes erupt with water or brine rather than molten rock. This possibility suggested that Ceres might be active geologically, which contradicted previous notions about this tiny planet. As scientists continued to examine the bright spots, the mystery grew more complex. What precisely were these lights, and what did they uncover about Ceres' geography? Might they at any point show progressing topographical cycles, or maybe something significantly more exceptional? These inquiries powered another influx of exploration as researchers tried to unwind the privileged insights of this far-off world. Ceres separates itself from different articles in the space rock belt by its size and mass, yet in addition by its extraordinary peace and the likely presence of water and ice. Not at all like ordinary rough space rocks, Ceres has a peace more similar to a comet, recommending it could hold fundamental hints about the early planetary group. The Dawn spacecraft finally made it to Ceres in early 2015, marking a significant milestone in space exploration after a 2-year journey through space. In stunning detail, the pictures it sent back showed a world that was once hidden in shadow. The first images of Ceres showed a surface that had been shattered by impacts for eons. However, the bright spots scattered throughout this alien landscape were what truly piqued the interest of space enthusiasts and scientists. As the goal of the pictures improved, researchers started to shape hypotheses about the beginnings of these spots. Could they be something even more unusual? Or were they simply ice patches that caught the sun's rays? Hypothesis went from mineral stores to indications of cryovolcanic action, every hypothesis offering an enticing look into the secrets of Ceres. Closer review uncovered that the most brilliant spot was not a lone component, but rather a bunch of particular spots. The most popular theory was that these were salt deposits formed when water sublimated. This proposed that Ceres, as opposed to past presumptions, could in any case be geographically dynamic, with processes equipped for carrying water or saline solution to the surface, where it rapidly dissipates, abandoning splendid intelligent deposits. These discoveries tested how we might interpret Ceres, portraying a dynamic and complex world definitely more captivating than anybody had envisioned. The likelihood that Ceres could hold onto pockets of groundwater or brackish water brought up significant issues about the potential for life in our nearby planet group. Ceres is a world of contrasts. It is an icy dwarf planet with a surface that is both rocky and porous. Ceres stands out because of its distinctive composition, in contrast to the majority of asteroids in the belt, which are primarily composed of rock and metal. It has a structure that is less dense than that of its rocky neighbors because its surface is a combination of water ice and hydrated minerals like carbonates and clays. This structure recommends that Ceres contains a lot of water caught inside its surface layer, making it more like a comet than a common space rock. The dwarf planet Ceres is thought to have a unique internal structure, with a mantle and a core rich in water ice that makes up about half of the planet's volume. This mantle is a combination of rock and saline solution, encompassing a center that might be made out of denser materials like silicates. The presence of such a lot of water ice on Ceres proposes that the planet might have once facilitated fluid water, particularly assuming its center was warmed by radioactive rot during its initial history. This inner design separates Ceres from its space rock neighbors, bringing up charming issues about its land action and the job water has played in its development. However, Ceres has more surprises in store. This dwarf planet may have formed in a much cooler region of the solar system before migrating inward, as evidenced by the ammonia clays found on its surface. The presence of smelling salts could bring down the edge of freezing over of water, possibly supporting the presence of surface saline solutions. Not only do these findings shed light on Ceres's composition and history, but they also shed light on the larger processes that control the formation and evolution of icy bodies throughout the solar system. Cryovolcanism, an interesting and entrancing land process, adds one more layer of interest to Ceres' story. Cryovolcanoes on Ceres release substances like water, ammonia, or methane, in contrast to the usual eruption of molten rock on Earth. Cryovolcanoes are the mechanisms by which these substances, which can exist as liquids or gases in the extremely cold environments of space, are expelled from the planet's interior. The salt water rapidly sublimates when it reaches the surface and is exposed to the vacuum of space, leaving behind salt deposits that are reflective. The bright spots that have captivated scientists and the general public are made up of salt residues. The most well-known of these bright spots can be found in the Equator crater, specifically in the Equator 5 region. This region has turned into a point of convergence for logical examination because of its high reflectivity and the intermittent clouds saw by the Sunrise rocket. These clouds are accepted to result from water sublimation, recommending that cryovolcanic movement might in any case happen, or if nothing else happened generally as of late, on Ceres. Ceres is home to several other bright spots, each with its own distinct characteristics, in addition to Equator 5. The dispersion of these spots across the dwarf planet's surface suggests that cryovolcanism may be more widespread than previously thought. The presence of these splendid spots difficulties the prior supposition that Ceres was a geographically inert world. All things considered, they feature its dynamic nature, uncovering a planet that is as yet developing with dynamic cycles that keep on forming its surface. A wide variety of Ceres surface features began to emerge as the Dawn spacecraft acquired more in-depth images. The Bantam planet's surface is specked with cavities, every one telling a piece of Ceres' long and wild history. Scientists can learn a lot about the processes that have shaped Ceres over billions of years from these craters and the bright spots. We are reminded of the vastness and complexity of our solar system as we continue to investigate Ceres and decipher its mysteries. Every revelation carries us one bit nearer to grasping the historical backdrop of Ceres, as well as the more extensive processes that have made the solar system what it is today. With its groundbreaking findings, the Dawn mission has challenged our understanding of planet formation and the possibility of life in the universe in addition to expanding our knowledge of Ceres. As we keep on investigating the universe, who can say for sure what other shocking disclosures look for us in the unknown regions of room?